So welcome back dear friends. In that now we are going to start our electrolytic refining. So basically it is used for copper, gold, silver, lead, zinc and aluminum. In this method the impure metal act as an anode. So see here impure, suppose we are doing of copper. So here impure copper is at anode and pure metal strip is taken as a cathode. So see this pure metal strip as a whatever that we are taking metal copper, and on that what is taken as a cathode. So both are it here both are same metal. So it here you have to taking care of that both whatever impure and pure of same metal only. So see these electrodes are separated in an electrolyte having, so that is soluble salts of the same metals. Means here we are using here coppers. One is impure copper at the anode and pure copper at the cathode. So we are to dipped in same salt solution. So here we took here CuSO4 solution, that is copper sulfate solution. We can say acidified copper sulfate solution. Okay, so acidified means few drops of concentrated sulfuric acid we added here because we want the conductivity fast or whatever migration of electron fast. Okay, so here join here battery also. Okay, so what will reaction happen here? Say once you start our electric circuit, so see here on passing electric current, metal ions from the electrolytes are reduced to metal, which is deposited on the cathode in the form of pure metal. See, after switching or after on this connection, so what will happen? Whatever impure copper means anode is what? So say here anox means always at the on the anode oxidation will happen. And red cat means what? Reduction on the what? Cathode. Okay, so see here oxidation reaction here on this anode. So what will happen after switching on this connection electric circuit? Whatever impure copper. Okay, so impure copper oxidation means what? Lose of electrons. So your reaction like that, Cu, that gives Cu2 plus 2 electron minus. So here our atom and charge. So keep in mind here A for atom, C for charge. So see here one atom, here also one atom. Here charge see how much? 2 plus 2 0, 2 plus 2 minus 0. So here also 0 charge. So it is what your oxidation reaction here. And reduction reactions here Cu2 plus means whatever that loose part they are taking here, whatever your pure copper here taking. So see here Cu2 plus 2 electron minus, that gives what? Cu. Means here also your atom balance 1 Cu 1 Cu, and here 2 plus 2 minus 0, here also charge 0. Means our reaction is totally correct. So whatever pure copper, whatever loose electron they are taking here in pure copper. So whatever losing this at the time of losing this electron, here some amount of impurity collecting. So that impurity we call it as a what? Anode mud. Okay, so it is what our electrolytic refining. But here we have to taking care of that whatever electrolytic solution of that same soluble salts of the same metal. Means here we use here copper, one is impure copper. So after switching on this connection, so lost this electron. So whatever lost the electron we are converted into here on the sorry we are that deposited on this cathode. So you will get what? Pure copper. Okay, means so basically this was suppose here thick. So after losing this become what? Thin, and this become what? This become thin, this become what? Thick. Okay, so like that we can do here electrolytic refining, and these reactions also important here. So these are examples we can do such type of refining on these metals. So we will see here or another part, alloys of different alloys are there. So in that first we'll discuss alloys of copper. So in that, as you know, bronze, so their percentage composition and uses also. So here in bronze, copper and tin. Copper 90% and tin 10%. Uses also there for making statues, coins, utensils. Then here brass, copper 80%, zinc 20%, condenser tube where we can use this condenser tubes, wire. So gun metal, copper 90%, tin 10%. Gun metal also here. Gun barrels, bell metals, copper 80%, tin 20%, bells. Okay, so we can use for this. Here German silver also there. So German silver basically copper here, copper 60%, zinc 20, nickel 20. So all these are what your alloys. So different their chemical composition also there with respect to their uses. Now we will see here some another also there, monel metals. So copper, nickel, for is okay, for storing of acids, that mono metal we can use. Alloys of silver also, coin is silver, as you know, silver solder, dental alloy for filling teeth. Okay, so basically these are important. All these chemical compositions. Then alloys of tin and lead alloys. Okay, here different stainless steel also there. So for making, you can observe here percentage also, iron, chromium, nickel, then carbon also. So many uses of there. Alnico, okay, chrome steel for making axle, then bearing, files, cutting tools. Now we will discuss here corrosion of metals. So in that corrosion of metals, what is the corrosion of metals? So slow destruction of metals due to chemical reaction on their surface by oxygen, CO2, moisture, SO2, H2S, okay, of the atmosphere is known as corrosion of metals. So these all factors are responsible for corrosion. So in corrosion, the metal atoms gives up electrons, that is they are oxidized and are converted into its ions. So basically suppose this metal, so this metal that gives what, m plus plus electron minus, means they lose their electrons, or we can say what, oxidize. So the ions move from one part of the metal to another part more easily in the presence of moisture. So very much important is the iron part, whatever iron moves from one part of the metal to another part more easily in the presence of moisture. So we can observe in our surrounding also with moisture what will happen. So see here, uh, this is because moisture provides a medium through the ions can flow. So here very much important this statement. Why moisture is responsible? Moisture provides the medium through which ions can flow. So that's why your metal gets easily corrodes. So we will see here corrosion of iron. How can we do? So rusting of iron also we call it as a corrosion of iron. So see, chemically rust is hydrated iron third oxide. So that is what Fe2O3 dot XH2. Chemical rust is what, hydrated iron third. Third means what, iron oxidation number. Iron third oxide Fe2O3 dot X62. So this X62 means what? The number of molecules attached is not fixed but always varies. So here very much important is whatever this X we are considering here X, and that X is what, it's not fixed but always varies. So see corrosion of copper, in that we discussed already this copper, corrosion of copper. You will get cuprous hydroxide and cupric carbonate as a green mass on your copper. Okay, and corrosion of silver we call it as a tarnishing of silver here. So see, when silver reacts with H2 is present in air to form a black coating. Okay, so whatever next part we will discuss in next lecture. Thank you.